Dear students, welcome to the fourth lecture on theory of equations. In this lecture, I will explain multiple roots and related results. First of all, let us look what is multiple roots. If alpha is a root of f of x is equal to 0, repeats r times, then alpha is called an r multiple root. If alpha repeats r times, then alpha is called an R multiple root. I will explain with example, in which a 2 multiple root is also known as a double root. Now let us look how these multiple roots came. For example, consider the function f of x is equal to x minus 2 whole cube into x minus 5 whole square into x plus 1. Here x minus 2 is a factor of this polynomial f of x in 3 times. That is, x minus 2 whole cube implies it is x minus 2 into x minus 2 into x minus 2. That means 2 comes 3 times as a root of this polynomial. Therefore, we can say that this 2 is a 3 multiple root. Similarly, in this polynomial f of x, there exists one factor as x minus 5 whole square. That means 5 is a root of this polynomial equation in 2 times. Therefore, we can say that 5 is a 2 multiple root, or we can say that 5 is a double root of this polynomial equation. And here minus 1 is also a root of this f of x. That is a normal root. So this is actually the concept of multiple roots. If a root of a polynomial function repeats r times, then that root is known as r multiple root. Now we can discuss one theorem related to the multiple roots. If alpha is an r multiple root of f of x is equal to 0, then alpha is an r minus 1 multiple root of f dash of x is equal to 0, where f dash of x is the derivative of f of x. Once again, if alpha is an r multiple root of f of x, that is, alpha is a root of this polynomial function f of x is equal to 0 and it repeats r times, then the theorem states that the same alpha is an r minus 1 multiple root of its derivative polynomial function, that is f dash of x is equal to 0. Now let us look the proof of that theorem. It is given that alpha is an r multiple root of f of x is equal to 0. Therefore, x minus alpha whole raised to r is a factor of this polynomial function f of x. That's why this polynomial function f of x can be written as x minus alpha raised to r into some phi of x, where phi of alpha not equal to 0, because if phi of alpha is again becomes 0, then alpha will be again the root of f of x, then that will be the r plus 1 root, r plus 1 multiple root. So here alpha is an r multiple root. That's why phi of alpha not equal to 0. Now let us find the derivative of this expression. Here you have to apply the product rule to find the derivative of the right hand side. Then f dash of x will be equal to x minus r or x minus alpha all raised to r into derivative of this phi of x, that will be phi dash of x, plus second function, that is phi of x into derivative of this x minus alpha all raised to r, that will be r into x minus alpha all raised to r minus 1. On the right hand side, here you can see that here x minus alpha raised to r exists in the first term, and in the next second term x minus alpha all raised to r minus 1 is exist. Now x minus alpha all raised to r minus 1 is common for both the terms. So you can take x minus alpha raised to r minus 1 outside. Then you will get x minus alpha into phi dash of x plus r into phi of x. Now whenever we are putting x is equal to alpha on this expression, then x minus alpha into phi dash of x plus r into phi of x will become r into phi of alpha, because whenever we are putting x is equal to alpha, this x minus alpha, this term will be 0. So the entire expression will be 0. Then you will get r into phi of alpha, and this already we discussed that phi of alpha not equal to 0 and r is a positive integer. Therefore r is not equal to 0 and phi of alpha is also not equal to 0. Therefore their product is also not equal to 0. Therefore we can say that x is equal to alpha is an r minus 1 multiple of f dash of x is equal to 0. Here we have already got that while taking f dash of x, x minus alpha raised to r minus 1 is a factor of this f dash of x. Therefore alpha is an r minus 1 multiple root of this f dash of x. And using this result, we have proved that alpha is not the root of again the root of this expression. Therefore it is not an r multiple root. Therefore we can say that alpha is an r minus 1 multiple root of f dash of x is equal to 0. So this is the proof of the theorem. Now let us discuss one problem that can be done by using the result or the theorem that we have discussed. Here the question is, solve x cube minus x square minus 8x plus 12 equal to 0 is a third degree equation, and one thing is given that this equation has a double root. X cube minus x square minus 8x plus 12 equal to 0 has a double root. That is the only concept they are given. From that one we have to solve this equation. Here the function is x cube minus x square minus 8x plus 12. Therefore its derivative f dash of x will be equal to 3x square minus 2x minus 8. Now we can factorize that as 3x plus 4 into x minus 2. Therefore 3x plus 4 and x minus 2 are factors of f dash of x. Therefore the roots of f dash of x is equal to 0 are x is equal to 2 or x is equal to minus 4 by 3. Here 3x plus 4 equal to 0 implies 3x is equal to minus 4. Therefore x is equal to minus 4 by 3. Here you can see that f of 2 will be equal to 0. Suppose we are putting x is equal to 2 in this expression, then f of 2 will be equal to 2 cube minus 2 square minus 8 into 2 plus 12, that is 0. And also you can see that x is equal to minus 4 by 3 whenever we are putting x is equal to minus 4 by 3, f of minus 4 by 3 not equal to 0. Therefore, 2 is a root of f dash of x is equal to 0 and 2 is a root of f of x. Therefore, we can say that 2 is a common root of f of x is equal to 0 and f dash of x is equal to 0. Therefore, we can conclude that 2 is a multiple root of 2 multiple root or double root of f of x is equal to 0. Therefore, x minus 2 whole square, that is equal to x square minus 4x plus 4, is a factor of the given polynomial function f of x is equal to x cube minus x square minus 8x plus 12. Now we can divide the given polynomial function with x square minus 4x plus 4, then we will get another factor x plus 3. Then f of x can be written as x square minus 4x plus 4 into x plus 3. So from this expression you will get two roots, that is double roots 2 and 2, and from this factor you will get another root minus 3. So the roots of the given polynomial functions are 2, 2 and minus 3. And there is an alternate method to do the same problem. Let f of x is equal to x cube minus x square minus 8x plus 12. When differentiating you will get 3x square minus 2x minus 8. Since the multiple roots of f of x is equal to 0 are also the roots of f dash of x is equal to 0 by the theorem, then the product of the factors corresponding to these roots will be the GCD of f of x and f dash of x. Now we can find the GCD of f of x and f dash of x by the division technique. Then you will get the GCD of f of x and f dash of x as x minus 2. Then since the GCD is common root for f of x and f dash of x, we can conclude that this 2 is a double root of f of x is equal to 0. Therefore, f of x has a factor x minus 2 whole square. Then we can write f of x is equal to x minus 2 whole square into x plus 3. Then as in the previous form, the roots are 2, 2 and minus 3. So this is the division process. From that division process you can find the GCD of the given polynomial function and its derivative. So that is the end of this section. Thank you.